this cable is going to be used for the self-running. This goes to this switch, and the motor is common, so that in this position would be powered from this cord. This position is powered from the wall. Just wanted to show back here that there's one white cord, and that's the cord going to the motor. It's right here, and it goes right here to the variac and through the bridge rectifier to the DC brushed motor, DC permanent magnet motor. And the white cord, we want to take a look at it here. It's going into this wattage monitor, power monitor unit. This cord is the one for the scope. It's plugged in here. The little white cord is for the lamp, and this black cord goes over to the other side of the lab here, and we can leave that out during the test just so there's no question. And we have nothing hidden here. You can see under the table, this is our ground wire that goes to a stake out in the yard, and that's not being used. We're not using the ground. We also have a antenna wire that we're not using for this setup. This is just just to show the basic generator power. You can see the exciter coils right here, and not connected to anything. Just wanted to show the open leads, the two leads here. So exciter coil and grounds and antenna are not in the circuit. I'll show you the output wires from the generator. These are the two start windings connected together. This is the output from the high voltage coil. One is going right to capacitor here. The other one comes out here, goes around the back to the other end of this capacitor bank. These are 1 microfarad at 5 kilovolts each. So they're wired in series, so the total capacitance is 167 nanofarad. You can handle up to 30 kV with that. And then the primary or the secondary output is right here. The two start windings again are connected together, and these are the two output leads. This one goes through the current monitor, current clamp, and there's two of them come out here to this terminal strip, which each pair of wires is connected to one light bulb, so we can just move the tap to change the load. So the only thing in circuit right now, this is the original setup, 6 light bulbs in series. These are 100 watt, 240 volt. So all we're using, the only instruments we're using for these 4 setups is going to be the scope and the current probe. And I have another one which we'll use to look at the primary. This is actually mounted here. It's mounted right to the wood. So, okay. So this is the first test setup. We're going to run it, and everything is going to be, all 4 tests are going to be done with 600 watts input, so that we have that for reference. And okay, I guess we'll get started here. Now this is just the standard output directly from the secondary into the light bulbs. we'll go to the next setup. I'm actually going to leave it just like it is with the load in the secondary, just as the conventional setup. I'm just going to move the scope and use the other current probe, and we're going to look at what the primary is doing during this test. There's no actual load on the primary. It's just doing the resonating. So okay, we're just going to look at the voltage at the output of the generator, or this is the primary winding, the high voltage winding. So here's the one lead exiting the generator, and that's connected here to the last capacitor. The other end of the coil is here on this end of the capacitor bank. So we're going to look with the scope right across the output, and we're going to use the other current probe and look at the current right here where it comes out of the generator. Disconnect the one probe and the other one's on. Okay, now this is just gonna show the bars, and the circuit that we're designing. We expect to recover all the reactive power, most of it, if not all of the reactive power. That's why we wanted to do it this way, to show you what's actually in this core. So here's what the high voltage winding is doing during the standard setup. So this is the new setup that some of our Canada guys came up with to get more power out of the generator. We're actually reversing the wiring so that the primary, the high voltage coil, will now be loaded with the the 6 light bulbs. We're actually going to use the primary as the output. Okay. In series and attaching this jumper to go over the longer one. I have a longer one. Somewhere here. Okay, so this is the output from the high voltage coil. We're going to connect that right into the load. It's tight. Okay, now the load is wired into the primary. And the secondary, we're going to attach these 12 capacitors. We don't have all the ideal values of capacitors, so we have to mix and match. So this is 14.2 microfarad, because there's the primary coils have about 26 henries of inductance, and the secondaries less than 400 millihenries. So need more capacitance. We're actually going to resonate the machine with the primary coil this time. One more jumper. And this should do it. Okay, so the only thing in the secondary circuit now are these capacitors. This is 14.2 microfarad at 900 volts. Okay, and we'll notice as we spin up the rotor, with this setup, there's actually 3 resonances. We're still developing, but the first 2 resonances do not phase lock, and you can actually dial right through them. So we're going to go to the main resonance now, and this is connecting to the terminal strip. Right at the output of the secondary coil. This here. Okay. And grab the other current probe. Oh, it's already connected there. Okay. So, got the loose current probe right where the output from the generator is, and the scope is connected right across the output here and here. Okay, so we will run it up. Set the input for 600 watts. that's what's going on in the primary wired as the output. And the final setup, we will look at what's going on in the primary coil during the test. So I've disconnected this probe so we can look at the 350 turn coils. I'm going to move the scope to the output right across the output of the 350 turn coils. The only thing in circuit with them now is this 14.2 microfarad capacitor. Okay, so this is the primary voltage and current. I wanted to mention the yellow trace is voltage and the blue trace is current. Test for today. Just wanted to show the amazing amount of power in this core. In a couple of weeks we should have our circuit developed to be able to extract all that reactive power. So thanks, and we'll talk again soon.